Hi everybody, my name is Nathan Stevens and here's my presentation and teachback for Project 3 named Objects and Components for Advanced Gameplay Programming class. So, as the other two videos, let's start off by clicking play and seeing what happens. So now we just have a black screen, but as we notice we actually have a bunch of images right here and they're all deactivated. And let's just click activate and we'll notice that all of them became active. Then we can click deactivate and they're all not active again. Now let's do show color R above 128 and we'll notice only a few of them are active. Show color G above 128, show color B above 128, sorted high to low, and then show all above 128. And if we click on something, it's going to show the color. So let's take a look at exactly what's happening here. Let's start off with events, and in this case the event that's taking place here, which is one of many actually, is when you click any cube, or rather any square, it outputs its color, the R, G, and B values. So this is happening because attached to every single square is something called event script, which I wrote. And it's a very simple script using the event systems part of Unity Engine, and it's using an interface called pointer click handler. And pretty much every single time that on pointer click, meaning every single time I click on any of the components that this has the script attached to, it's going to output to the debug log the color, which we can see right here. And the reason that each color is multiplied by 255 is because in Unity the colors go from 0 to 1, and if you want to convert it to the standard 0 to 255 value that you see on many RGB measurements, then we have to multiply each value by 255. So once again, this is an extremely simple one-line event, but as we can see, every single one has the event script attached to it, so that when we click on it, it outputs the color. And now let's talk about object pooling, because that's one of the main functionalities of this entire project. So as you can see, we have something called object pool right here. And this is the script where right now the size is 0 because that's the list. But what we want is that we want to create 1,000 different objects when it starts. And this happens in the awake function of our object pool manager script. Or actually it happens in the start function. So right now it says start create pool, and so let's go to our create pool function, and it's all the way at the bottom over here. As you can see, this is how we created. But let's go back here for a second, and we also pick our pool object. In this case it's image random color, and here it is right now. It's deactivated, but right now here it's activated. So what we do is that when we create the pool, we create a temporary game object and we instantiate it, and then we're going to set it active as false. So that way, whenever we press play, we have everything already here, but none of them are showing. And the whole reason behind object pooling is so that it's very good in terms of memory. So for example, if we had a bunch of bullets and we kept activating them, or rather we kept instantiating brand new ones and then destroying them when they went out of focus, if we have a million flying bullets, that's going to take such a load on the system, and it's going to really cause some frame skips or frame jumps. It's just not a really smart way to program. The much smarter way is to use an object pool in which everything is already active, and that would be the point of having a loading screen, so that we can load everything during the loading screen, and then we simply set objects to either active or inactive. In this case, we would activate all of them, and here we would make them all inactive. So what I'm doing is that I'm taking this white image that we can see right here. This is the base image, it's just white. And what I do is that I create a new one based off of it. I set the active to false so that it's not active. I create a new random color, and this is what I was talking about earlier. It's from 0 to 1. That's how Unity measures their colors. I create a random position for it. And as you can see on here, this is just based off a standard 1920 by 1080 screen. So that's why it's negative 910 to 910, because each square is a width and height of 100. And then I set the temporary game object's color to the random color I made, and then I set its parent to a game object called image holder, which is right here. Because if we don't, then it would just be created. For example, when I press play, it's all under here, so I can easily just shrink it, and now there's not so many objects. Whereas if I didn't put it under some sort of game object, then it would just be like this, and I would have to keep scrolling every time I want to access anything. It also serves another purpose, because then it knows that the parent is image holder, so when I change its anchored position, it's going to correctly place it within the frame, whereas if I hadn't changed it, then a lot of them would have been out of the frame. And then I finally add it to the pool. So this way, all of the images are added, but none of them are activated because we never clicked the activate button. And all of these buttons also go back to events, because all of here we have on click, that's a Unity event, and it takes all of the functions from the object pool manager that I wrote from this script right here, and the reason that I can access them is because I made them public. So for example, R button, which is right here, it says that on click you take object pool, which is right here, because this is where the script is, and let's go back to R real quick, and it says filter R above 128. So let's see what happens when we filter R above 128. And this will also gonna get into link filtering. So right now it says create a list of squares that have an R value of above 128. And the reason is that it doesn't say 128 here is because, like I said, in Unity colors go from 0 to 1. But the equivalent of 128 is about 0.5. So we're going to say list game object red above 128. And this is where our link comes in. So we're pretty much filtering an item from pool, because that's our main list, which has everything. So when I click activate, it activates everything in the list. But what this link query is going to do is it's going to take every item in here and it's going to say, okay, let's look at the R color component of the image, and if it's above 0.5, let's put it in this list. And it's going to take all of those and it's going to create a list out of that. So in order to show only R like this, what it does is that we deactivate the entire pool, and immediately we're going to set all of the red ones in this list to true. So even though we're deactivating it first, the user can't see it because it's pretty much instantaneous. And we can easily check the color, because if we just click it, we can see we're just going to look at this 198 right here. So I can just randomly click, and I'm just clicking randomly, and we can see everything is above 128 in the R section. All of these are above 128. I can just keep clicking and clicking, and all of them are above 128. It's the exact same for G. The only difference between filter R above 128 and filter G above 128 is that instead of doing color.R greater than 0.5, we're doing color.G. And this way, when we click show color G above 128, it shows the ones with the G above 128. It's pretty self-explanatory, at least the title of the function. And as I click around, you can see that, I mean, sure, it comes close, it's 139, but nothing is ever going to be below 128. Whereas a lot of the other B's or the R's, those will be under, because we're not sorting that. And as you can see here, show color B above 128, it also says high to low, which means that we're also going to be using link to sort it. So what we do is we deactivate. This section is the same as all the other ones, just B instead of G or R, it's B. We deactivate it, and then we sort from highest to lowest, and we send the list along with the color blue. And what we're doing here in this function is, in the case of blue, we're going to make a sort. We're going to order it by. So we do from the item in my list, because notice that we passed the blue list as a parameter when we called it. Let's scroll up really quickly, and we passed the blue list, which is already a link filter. So we're going to pass a filtered list and sort it. And we're saying order by item.getComponentImage.color.b, and by default it's going to order the blue from highest to lowest. If we wanted to order it by lowest to highest, we would simply put descending right here. Then we do select item.toList. So now we have a new list that is not only filtered with just blue above 128, but it's also sorted from high to low. And then what we do is we want to be able to see it easily in our hierarchy, so we just do a simple for loop with I starting at 0 like all the rest, and we're going to set each one as the first sibling. So this way, when I click show color B above 128, not only does it happen that when I click all around, all of the B values are above 128 as we can see, but if we expand the image holder, we can see that this should be 255, and it's going to slowly decrease. Like here's 252, we're going to go down a bit, 245, until at the very bottom, it seems like there's a lot of B's. Yeah, right here, it should be almost 128. And yeah, it's right here, it's 128. So as you can see, these are the least B values, and this is proving that it is sorted highest to lowest, that at the very bottom of the list, it's 128, and it goes up from there. And now we see another button, which is showing all the R, G, and B values above 128. So when we click it, it's not going to be nearly as much, but as I click around, let me lower this console, as I click around, it's clicking randomly everywhere, we'll notice that all of these values, see this one is 129, that's still above 128, they're all above 128. And in order to do this, let's go back to, it's actually up here, filter all above 128. And what we do is we take the same lists that we did above, and we're going to combine them. So these are the same queries from the 3 previous functions of filtering them through link, and then we make a new list called all above 128. And all that we do is we use the intersect method to link all of them together. And it could have been any order. I just did red, green, blue because that's RGB, but it could be blue, green, red, blue, red, green, whatever you want. And then the same logic applies. Once we have our completely filtered list, we deactivate the pool, and then we set all of them to active. So this way, when we show all of them, it's going to show, so let's activate all. As you can see, it's a lot of them. As we click, it shows everything. Notice that some of these are below 128. It doesn't really matter because it's showing all. But when we do show all above 128, it's only a select few. And now let's do another example. Instead, let's just do, instead of pool size of 1,000, let's just do 10 of them. So let me save it really quick. Let me press play. As you notice, it's only 10. So when I activate it, right now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now let's deactivate, activate, show R above 128. So as you can see, these all have a value of R above 128. Let's show G above 128. Only these 3 have it. Show B above 128, and let's do show all. So as you can see, only these 2 have it. And I mean, the pool size, it's really good to be using it when you have a lot of images or a lot of objects. So let's say we have 10,000 squares. And when I press play, it's going to take a bit, and it loads right now, and I activate it, and it shows everything. And let me do show R above 128. It filters it all. Show G above 128, show blue above 128, and show all above 128. So I hope you learned a little bit about object pooling, about events, and especially link, both filtering, sorting, and intersecting. I think it's pretty important to learn, and it's really fun, especially if you have experience with things like MySQL or PHP or any database sort of thing. It's really fun to learn. So thanks for watching.